my name is Jaden Elgin, and today I'm here to talk to you about the 3 laws of motion. The reason why I chose to do this topic is because I really believe that no one really cared about this during the first 6 weeks. Like, we watched boring videos, and I really didn't remember this until I did this project over it again. So I thought I should remind you all about what these 3 laws were about and why they're so important to our everyday lives. Alright, now that I've gotten that out of the way, let's talk about the 3 laws of motion for a second. These 3 laws first appear in his masterpiece, The Principia, in 1687. He created these laws in order to explain why the planet's orbits are ellipses rather than circles. Even though Newton's laws were replaced by quantum mechanics and relativity as the most fundamental laws of physics in the 20th century, they still managed to give an accurate account of nature, disregarding small bodies such as electrons or bodies moving at the speed of light. Now that that's out of the way, let me break down the 3 laws of motion for you. Newton's first law, otherwise known as the law of inertia, states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless it is acted upon by a force. Which essentially means an object at rest will stay at rest and an object in motion will stay in motion unless acted on by opposing force. So for example, if no force acts upon this sandbag, it will stay in the same spot indefinitely. However, if a force acts upon the sandbag, then it will keep moving at a constant speed and in a straight line until being slowed to a stop by the force of friction. If the force of friction didn't exist, then the sandbag will keep moving in the same direction forever. Newton's second law states that acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. So basically, if the object is light, you will need less force to accelerate it. If the object is heavy, you will need a lot of force to accelerate it. Unlike the sandbag, the statue of Mario had a lot more mass, meaning that it would require a lot more force to accelerate it than the sandbag did. Newton's third law states that for every action, there is an equal and opposite reaction. This basically means that whenever an object pushes another object, it gets pushed back in the opposite direction equally hard. For example, right now, everyone is passively applying force to the ground, and in turn, the ground is pushing back equally as hard in order to support your weight. It may not seem as important as I made it out to be, but look what happens if I turn off the third law for like 3 seconds. Well, that's everything I know about the 3 laws of motion, and I hope you enjoyed this presentation, and I hope you leave here having a better grasp of them, and don't just forget them in the next 5 seconds, because, well, yeah, that would suck.